In this lecture, I'm going to show you that constructible numbers form a field. So to show this, it's sufficient to prove that if I have two constructible numbers, then A plus B, AB and A inverse 1 over A are constructible. So to do this, we'll make use of a certain very standard construction with straight and compass, which is the construction of parallel lines. Of course, I'm sure you've seen all this before, but let's just do this carefully once using GeoGebra. So the construction is the following. You're given a line L here and a point P, and the task is to construct a line that passes through P and is parallel to L. Now the first step in such a construction is to somehow find a point Q that lies on the line L. So to do this, usually you're given, so remember when we talked about what a constructible point is, we always started with given 2 points which we called O and A. So if the line segment O and A is not parallel to the line L, then you can just extend it to intersect L at some point, and that could be your point Q. If OA is parallel to L, then you could construct a line that's perpendicular to OA, something we did last time, and then that line would intersect the line L in a point which we would call Q. So in any case, you would be able to somehow find a constructible point on Q. So somehow construct a point on Q, and then we can start our construction. So what you do is, the first step, you draw a circle with center at Q and passing through P. Okay, and now you mark as C the intersection of this circle with the line L. Now let D be the distance between the point P and C. So this distance, we are calling it D. And let E be a circle passing through P with center Q. So I have a second circle now with center P and passing through Q, and the idea is I will measure off an arc on this circle E centered at Q with the same arc length as the arc of the circle C passing through P and capital C. So what I'll do is I will draw a circle F with center at Q and radius equal to D. D is the distance between P and capital C. And then I take capital D to be the intersection of the circle E with the circle F. And now let's define a line M that passes through P and D. Then L is a line that's parallel to M is a line that's parallel to L and passes through P. Okay, so with this construction, you see that it's possible, given a point, a line and a point not on it, to draw another line that's parallel through to the original line and passing through the given point. Okay, so now we'll use this construction of parallel lines to construct products AB and A inverse. It's quite easy once A and B are, if you have points distance A with the distance A between them and another pair of points with distance B between them, then it's very easy to construct 2 points with distance A plus B between them. You just take along a line, you first take an arc of mark off length A, and then you mark off length B using your compass, and then totally you would have marked off A plus B. So the interesting questions are, given A and B, can I construct AB? And given A, can I construct A inverse? So we look at those constructions. So now let's assume I'm given two lengths A and B. So what I'm going to do at first is I'm going to construct a right angle triangle like you see here on the left hand side with base 1, and that base could be the original points given O and A, and I'm going to erect a perpendicular at A, at capital A, of height little a. So I'm just going to mark off little a along this perpendicular line. So I have this right angle triangle OAB, and the idea is to construct another right angle triangle whose base is B. So how do you do that? Well, you mark off the length B again somewhere along this line passing through O and A. And so I've marked them off here. The distance between the points C and D is little b. And then you draw a line through C that's perpendicular to this line through O and B. Okay, that line segment we called R. So we are drawing something that's parallel to R and passing through C. And then you also draw a line that's parallel to AB but passes through D. So what we have in effect is a triangle so if I call this new point E the intersection of these two lines, then we have a triangle CDE that is similar to the triangle OAB. Okay, and so if you ask what is the length of this line segment E by D, then the length of the line segment E by D divided by B is the same as the line segment A by B divided by 1. So that means that the line segment ED has length A times B. And so given A and B, we've constructed the product AB. So now it remains to show that if I can construct A, then I can construct A inverse. So the idea here is very similar to the construction of AB. It's a slight variant, again using similar right triangles. And I'll just show you the general idea and leave you to fill in the details. So the point is, you start off with a triangle OAB where the vertical edge is of length A. And then you construct a triangle that is similar to it. Let's call it O prime, A prime, B prime, where the vertical edge is of length 1. Now if this the ratio A over 1 is the same as the ratio of 1 over this edge O prime, A prime. So that means that this O prime, A prime is of length A inverse. And so if you can construct A, then you can also construct A inverse using straight edge and compass. And this shows that all constructible numbers indeed form a field.